Okay, so this is chapter 3A, day 1. We're going to solve with addition and subtraction. We start simple and then we work our way up. So the first thing we're going to do is review some terms. And the first one of those terms is opposite numbers. Opposite numbers. So the phrase opposite numbers comes because the numbers are on opposite sides of 0. So an example of that, of opposites, would be -4 and +4, because both of them are a distance of 4 from 0, so they're called opposites. The purpose of opposites for what we're going to be learning is that the sum of opposites always equals 0. And that's a quality that we're going to use in order to solve things. So again, taking our last example, if I take -4 plus 4, so I find their sum, -4 plus 4 equals 0. So we're going to use that to our greatest advantage. Those are opposites. The second term is reciprocal numbers. Reciprocal numbers. And you've already heard me say reciprocal when we did stacked fractions. It's the same word. But in this context, reciprocal numbers are two numbers whose product equals 1. And product means multiply. So two numbers whose product equals 1 have to be reciprocals. And again, this is something we use in solving. So an example of reciprocal numbers would be 2 and 1/2. The proof that these are reciprocals are if we multiply them together. So if I multiply 2, put it over its invisible 1, times 1/2, tops times tops, bottoms times bottoms, you get 2 over 2, which is a 1. That's how you know that those are reciprocals, because their product equals 1. This is going to come in especially handy with fractions. For example, -4/3. The reciprocal of -4/3 is 3 over -4, or -3/4. Notice that the reciprocal has the negative on it. That does not go away. A reciprocal of a negative number is a negative number. Okay, so the proof, if we multiply -4/3 times 3 over -4, we multiply them together or find their product, that equals -12 over -12, which is a 1. So reciprocals are numbers whose product equals 1. Okay, third word. Inverse operations. And I'm mainly giving you this one to help you with some of the questions on the worksheet. They ask you for inverse operations. So I'm just going to give you an example of what you're going to see on their worksheet. On your worksheet, they're going to have something like add -3, and your job is to give the inverse operation. The inverse of add -3 is subtract -3. Notice the -3 doesn't change, only the operation changes. So if it was multiply, what would be the inverse operation of multiply? Divide. Yeah, so those two are inverses of each other. Okay, so those are the vocabulary words you need. So Roman numeral 2, we're going to do solving steps. And solving steps are what we use when there's a problem that has multiple steps. And if you don't know what to do, your fallback is to go to the solving steps and just walk through step by step. So first one is to simplify both sides. And by both sides, I mean of the equal sign. Simplify both sides. Now, we've actually been practicing to get you ready for this. We have done order of operations. That is something that you use to simplify. We have done add or subtract like terms, add an x to an x, a number to a number. That is a part of simplifying both sides. We have been practicing distribution property, which also is a simplifying move. And last, we've been working with absolute value. So all those skills that we've been practicing for the past month are now going to get used in the very first part of solving. So that's the first step, is you simplify using any or all of those, the left and the right. Okay, now step 2. Step 2, you're going to add or subtract to get x terms on the left and number terms on the right. Now, there are ways of reversing this, but in the beginning, we're going to be very strict about going left and going right because that is actually the places those need to go. So add or subtract to get x terms on the left and number terms on the right. And to do this, we're going to use opposites. All right, that is step 2. Now we're going to go on to step 3. Step 3 is multiply or divide to get a 1x equals your answer. Multiply or divide to get 1x equals your answer. And to do this, we're going to use reciprocals. So steps 1 through 3 are your basic solving. The fourth step in the beginning won't be necessary because the problems we're doing are really, really easy and the chances you're going to get an extraneous solution are pretty slim. But as the problems get more difficult, the likelihood it could be extraneous is a lot more prevalent. So step 4 is to check your answer or answers, depending on how many answers you have. And again, we've been practicing this already when we did evaluating. You're going to substitute in the answer, simplify, and then the question is, does the left equal the right? If the left does equal the right, you have the correct answer. That is the ultimate test of any answer, is does it make the left of the equation equal the right, in which case it is actually the real answer, the real solution. All right, so those are the 4 basic solving steps. Okay, so Roman numeral 3, we're going to go to examples. Now, this is the part where I'm going to require that you show work in a certain way. After this unit, you will be allowed to solve showing work however you want. But by then, you might see why it's the useful way to do it. But in the beginning, we're going to do it very uniform. So first thing is you need to show all solving steps. They're going to be so easy you can guess them, but that's not the point. The point is to start getting your work to be shown in a way that we can expand on. And we're going to go downward. Why? That's how the Greeks did it. I didn't invent it. Second, you're going to add or subtract terms to both sides. So most actions that you're going to do will happen twice. You'll do it once on the left and once on the right. And then I'm going to show you reciprocals, which will be new for some of you. We're going to do x divided by a reciprocal on both sides, which again will happen twice. All right, let's do an example. And again, I know these are easy. You do not need to tell me they're easy. I'm aware that they are because we're trying to learn how to show our work in a way that we can build on it. So 12 minus x equals 24. Now, one of the tricks that I use is to put a line down the equal sign because that reminds you to show everything on both sides of the line. So in our solving steps, step one is to simplify. Most of the ones on tonight's homework are like this. You can't really simplify anything. You can't add a 12 to an x. Not possible. So a lot of times you're good to go on for the second step. Second step, add or subtract to get x's left. It's already on the left and numbers on the right. My number 12 needs to move to the right. We're going to use its opposite. The opposite of 12, I'm going to highlight it so you know which one we're looking at on your notes. The opposite of 12 is negative 12. So we're going to subtract 12 on the left, which means we have to subtract 12 on the right. Why? Because there's an equal sign. That means you have to do everything equally to both sides. So if you do this right, the opposites should add up to 0 because that's what opposites do. 12 minus 12 goes to 0. I now have a negative x equals 24 minus 12, which is 12. All right, if you don't have a number on the x and you just have a negative on the x, the process to remove the negative is to multiply both sides by a negative 1. And a negative times a negative is a positive. So you have a positive x or a positive 1x. And then 12 times negative 1 is negative 12. So you can show and put a box around your answer. You can show it 1x equal 12, or you can just do x equals negative 12. X and 1x are the same thing, so you can show that. All right, let's do another one. Example 2. We're going to do negative 10 equals 2y minus 2. And again, I'm going to put a line down the middle of the equation because it lines everything up. Okay, so first step is simplify. Well, there's nothing to simplify. We can't add a y to a 2, and there's nothing else. So we're ready for step 2. Add or subtract to get the x term left. I need this 2y to move to the left. So I'm going to use its opposite, which is negative 2y. So I'm going to subtract 2y, which means I have to do it on the left. But don't put it under the 10 because you can't put a letter term and a number term together. Put the minus 2y by itself so you don't accidentally add that. And of course, 2y minus 2y, because they are opposites, goes to 0. And I have negative 2y minus 10 equals negative 2. And you can slide your negative 2 over a little bit because you got rid of the y's. So now we're still on step 2. The y is now on the left. Now we're going to add or subtract to get the number on the right. So the term that needs to move is the negative 10. That's the number term. It needs to be on the right. The opposite of negative 10 is positive 10. So we're going to add 10 to both sides, left and right. Everything you do should look the same to the left of the line and to the right of the line. As usual, opposites add up to 0. 10 minus 10 is 0. I now have a negative 2y on the left and an 8 on the right. Now again, I'm showing you a way to do this you might not have seen. we're on to step 3, multiply or divide by the reciprocal. I'm going to train you with reciprocals because if you can do reciprocals, when I show you fractions this year and in Algebra 2 and in pre-calc, you will have no problem with them. Like they won't even be an issue. And that's what we want, is for you to be able to do fractions. So put these both over their invisible 1. You're going to multiply the left by the reciprocal of -2 over 1, which is 1 over -2. And you're going to do the same thing on the right, 1 over -2. That's the reciprocal. Now, the cool thing about reciprocals, remember doing this on stacked fractions? When you multiply reciprocals, they cancel out to a 1. So I get 1y equals, and 8 divided by -2 is -4. And again, you can show it as a 1y or just a y. Either way is fine. All right, I'm going to flip the page because we're going to do an example with an absolute value. Example 3, and I'm going to move a little faster because we're getting to know the steps. So 11v plus the absolute value of -5 equals -40 plus v. I'm going to draw a line down the middle. Okay, step 1, simplify. This one, we have something to simplify. We can simplify the absolute value. And the absolute value of any number is positive. So this is going to be 11v plus 5. And we just recopy the rest, equals -40 plus v. And we are simplified. I can't add a v to a number, so there's nothing else to do for step 1. Step 2, add or subtract using opposites to move the x term left. The one that needs to move is this v. It needs to be on the left. So the opposite of positive v is negative v. So I'm going to subtract v from both sides. V minus v is 0. So now I have a -40 by itself. On the left, 11 minus 1 is 10v plus 5. I have moved all of the v terms to the left. Now I need to move the number terms to the right, which means the 5 is on the wrong side. It needs to be moved. The opposite of positive 5 is -5. So I'm going to subtract 5 from both sides. 5 minus 5 is 0. I now have 10v equals -45. Right, we are on step 3. Multiply by the reciprocal to get the v alone. So put these over their invisible ones. And I need to get the 10 off of the v. So I'm going to multiply by the reciprocal, which is 1 over 10 on both sides. When you multiply something by its reciprocal, it cancels to a 1. So now I have a 1v equals, and I have -45 over 10, which reduces to -9/2. All right, last one on the notes. 2 plus x equals 3x plus 4 minus x. Draw a line down the middle. All right, step 1 is to simplify. On the left, I cannot add a 2 to an x. On the right, though, I have a 3x and a -x. I can add those together. 3 minus 1 is 2x. Recopy the rest. All right, we are simplified. Ready for step 2. Add or subtract to get the x terms left. So the one that's on the wrong side is the 2x. The opposite of 2x is -2x. So I'm going to subtract 2x from both sides. So on the left, I have 2, and 1 minus 2 is a -1x, equals, and then slide the 4 over. All right, so my x's are left. Now I'm going to add or subtract to get the numbers to the right. The 2 is on the wrong side. Needs to be on the right. The opposite of 2 is -2. So I'm going to subtract 2 from both sides. 2 minus 2 is 0. That's what opposites do. And I have a negative x equals a 2. Now, just like the problem before, to get a -1 off of an x, you can just multiply both sides by a -1. And a negative times a negative is a positive x. And a positive times a negative is a negative. 2 times 1 is 2. This way of doing it will help you later when we have more than just a number over there. So that's why I'm having you train that way. Okay,